Hi guys, I am Chakwa and I am back with Maths XYZ, and today we'll be continuing with trigonometry on reduction formulas. So reduction formulas enables you to write any trig ratios in terms of an acute angle. Remember, an acute angle is any angle which is less than 90 degrees. Then let's just first do a bit of a revision from what we have already done from our last session, which is trigonometric in Cartesian plane and also trigonometric identities. So first, let's look at trigonometric in Cartesian plane. All right, remember we have x and y axis, of which this is 0 degrees, this is 90 degrees, 180, 270, and 360. Of which, remember when we were doing trigonometric in Cartesian plane, this was cast. Of which, to make it easy for you to remember, it says all students take care. All right. Then we know that from in the first quadrant, which is this one, this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Alright, then in the first quadrant, all trigonometric ratios are positive. That means sine is positive, cos is positive, and tan is also positive in the first quadrant. Then when we move to the second quadrant, of which we can see that it's sine with an S, then that means only sine is positive in this quadrant. Then this is sine, only sine, it's positive in the second quadrant. Then when we move to the third quadrant, it means that I start with a T, which you see, that means that it's tan, only tan in this quadrant, it's positive. And in the fourth quadrant, only cos, it's positive in this quadrant. Then, okay, then when we are looking at reduction formulas, in the first quadrant, we have 90 minus theta, of which if sine into 90 minus theta, that means that it's equals to tan theta, because all trigonometric ratios in the first quadrant are positive. Then when we move to the second quadrant, remember this is 90 degrees, that means that it's 90 plus theta. And then also we have 180 minus theta. Let me just use a different marker so that we can see, because we're going to be writing a lot of things in this. So when we're doing the reduction formulas, let's use a different marker. This is 90 minus theta. And in the second quadrant, we have 90 plus theta. And also we have 180 minus theta. Do you see how this comes around? Because here, it's 90 degrees. That means in the first quadrant, because it's below the 90 degrees axis, that's why it's 90 minus theta. Then in this axis, in this quadrant, which is the second quadrant, we have 90 degrees there, then it's 90 plus theta, because the sine is after the 90 degrees axis. And then 180, because it's behind it, that's why it's 180 minus theta. That means here, because it's after the 180 axis, it will be 180 plus theta. Then this is the third quadrant, we have 180 plus theta. And also we have 270 there, which will be 270 minus theta in this quadrant. Alright, when we go to the fourth quadrant, we have 270 plus theta and 360 minus theta. And also 360 is this axis, and it also affects the first quadrant. That means in the first quadrant, we also have 360 plus theta. Alright? Okay, remember guys, in the first quadrant, all trigonometric ratios are positive. In the second one, only sine is positive, and in the third one, only tan is positive, and lastly, in the fourth quadrant, only cos is positive. That is when we are dealing with trigonometric ratio in Cartesian plane, of which this is what is going to help us when we are answering question in trigonometric on reduction formulas. All right, let's look at one example here of trigonometric ratio in trigonometric in reduction formulas. Okay, I'll just erase this, guys. I hope you saw how to do this, and you already took the Cartesian plane, you copied it into your box. Then let's do an example. All right. All right, an example. The first one, which says cos 180 plus theta. Alright, multiply by sine 360 plus theta. Alright, and then divide by cos 360 minus theta, and also sine into 180 minus theta. All right, okay. The second step, the first step that you do, remember 180 plus theta is on the third quadrant, which means only tan and that quadrant is positive. Then if we have cos into 180 plus theta, that means it's negative cos. 180 plus theta is in the third quadrant, of which at that quadrant cos is negative. All right, then that means that we have negative cos theta because 180 plus theta is in the third quadrant. All right, when we come to sine 360 plus theta, remember 360 plus theta, it's in the first quadrant, of which in the first quadrant all trigonometric ratios are positive. All right, that means that we have a positive sine theta, which means it's sine theta positive, right? And then divide by cos 360 minus theta. Remember, in the fourth quadrant we have 270 plus theta and also 360 minus theta. That means in the fourth quadrant cos is positive. Then that means this one, it will be positive cos theta. All right, and then the last one, which is sine 180 minus theta. Remember, 180 minus theta is in the second quadrant. That means that cos sine is positive because it's in the second quadrant, of which only sine is positive. Then we will have sine theta there. Then from here, this and this will cancel out, this and this will cancel out, and we'll be left with -1. All right, I hope you guys understood this question. This was just an easy one so that we can understand how do we solve question on reduction formulas. If you are given anything, you just have to remember, always write your trigonometric on Cartesian plane down, so that you write all the trig ratios, and you also write which one is positive in which quadrant, and you also write the angles then. And when you are done with that, you can now attempt the question. Like for this one, you just look back into your Cartesian plane and see is 180 plus theta in a quadrant where cos is positive. Obviously it's not, then, because 180 plus theta is in the third quadrant, of which only tan is positive in that quadrant. And from there, you know that means that your cos is negative. And then when you move to the second one, which is sine 360 plus theta, you know that 360 plus theta is in the first quadrant, of which all trigonometric ratio are positive at that quadrant. That means that sine theta, that means that it will be a positive sine theta. Then you move on and doing that all the time. That will be better for you, because you will have all your Cartesian plane down and all your trig ratio written down. You just look back into it, and then you will be able to attempt the question more easily. All right, I hope you guys understood this example. If you didn't, just drop a comment note, then we'll have a follow-up on it and help you to understand even more better. All right, the second one, it says sine squared 360 minus theta. Sorry guys, I made a mistake there, copy mistake. 300 minus theta multiplied by cos okay, I need a lot of space. That means that I have to write small letters. All right, starting again, this is sine squared 360 minus theta multiplied by cos 360 minus theta multiplied by cos 180 plus theta. All right, that's theta there, guys. All right, okay, from here, the first one is this one, which is sine squared. It has a square there, 360 minus theta. When you solve this one, I'm just going to take this one as a portion on its own. When you solve it, it says it's sine 360 minus theta. This time, it does not have the square. Then you have this big brackets and you square it there. All right, do you see it, guys? It's sine squared 360 minus theta. Then just taking this portion down so that you can understand more better. Then it's 360, sine 360 minus theta, have big brackets and then square it. Then with this one, we know that Sine 360 minus theta is in the fourth quadrant, of which at that quadrant only cos is positive. That means that sine is negative at that quadrant. Then inside the brackets, still first solving what's inside the brackets, it will be negative sine theta, because sine theta is negative at the fourth quadrant. Alright, then this will be negative sine theta. And remember, we still have those brackets squared. Then anything, when you square a negative 1 squared, it will give you 1, positive 1. Then negative sine theta squared, it will actually give you sine squared theta, like that, positive sine theta. Alright, now that means that sine squared 360 minus theta, you have your answer as sine squared theta. Alright, coming to cos 360 minus theta, remember, cos is positive at the fourth quadrant, of which at the fourth quadrant we have 270 plus theta and 360 minus theta. That means that cos is positive there. Then we have multiply by cos theta, which is positive. And then coming to this one, which is cos 180 plus theta. Remember, cos is positive at the... Okay, guys. Cos is positive at the fourth quadrant, and 180 plus theta is actually at the third quadrant, of which only tan is positive at that quadrant. That means that we have cos negative, oh sorry, this is negative cos theta. Alright, now we have sine squared theta, and that one will be negative cos, multiplying this to negative cos squared theta. That will be our answer. Alright guys, we have sine squared theta multiplied by cos squared theta. Remember, we can say this is equals to 1 because it's not an identity. Just a quick revision on identities. Identity, it says that sine squared theta plus cos squared theta is equals to 1. Not the other way around, not multiply by, not minus, and not also division. It's only when it says plus cos squared theta that it makes it an identity. Then this one will leave it as it is because it's not an identity and it's not anything. It's just sine squared theta multiplied by cos squared theta. But then we can actually still continue from this one by changing one of the trig ratios so that we can have our answer in only one trigonometric ratio. For example, remember in identities it says sine squared theta plus cos squared theta is equals to 1. That means that sine squared theta is actually 1 minus cos squared theta. Alright, and then from here we'll have 1 minus cos squared theta multiplied by negative cos squared theta. Alright, and then from here we'll have this multiplied by that, it will be negative cos squared theta, and then this multiplied by that, it will be plus cos squared, actually 4 times, it will be cos to the power of 4 theta. Then we'll leave it as it is there. Alright, that's only when you still want to continue from this, then that means that your answer will be cos squared theta plus cos to the power of 4 theta. Alright guys, I hope you also understood this question, this example. Remember, always have your Cartesian plane written down, so that when you are answering question, you just refer to your Cartesian plane, and that will make it very, very easy to answer the questions on our reduction.